Hi, and welcome to this lecture on modules. In this lecture, we are going to learn about what modules are, how to use them, and some common errors. Let's click in our script editor or in our viewport. To get to our script editor, we will press and hold our spacebar, go up to panels, click, drag down to panel, and then go down to script editor. We can clear our output from our output window. And then within history, make sure that you have line numbers and errors ticked on and show stack trace ticked on. What are modules? Python modules are files, just files containing Python code that can be imported and used in other Python scripts or programs. Modules are an essential feature in Python as they enable developers to organize code into reusable and easily maintainable parts. A module can contain variables, functions, classes, or even other modules. By importing a module, you can access its contents and use them in your code. So Python provides many built-in modules, though, such as math, random, datetime, that you can use without having to write them yourself. And we'll touch on a few of those right now. But okay, let's jump in. All right, how to use them. To use a module in your Python code, you need to import it using the import statement. So for example, to import the math module, you just have to write the following piece of text: import math. Now, I'm going to guess that you followed that. See, that's why we love Python, because it's just simple. And then highlights within Maya, this is what you do. Obviously, within a module, within a file, when you're running your code, these all just execute on runtime. But, okay, within Maya, we have to highlight it in our viewport, okay, or in our script editor, and then we click and press Control, and then click Enter. So now we've imported the math module. Now, the math module has a lot of contents, okay? And I've got the link to the Python docs so that you can have a look through some of the various other incredible functionality with the math module, okay? You very rarely have to write complex math modules, okay, looking, essentially using basic math, because a lot of those complex initial steps have been taken for you. So then mostly it becomes about functionality for your writing. But to access the math modules, all you have to then do is use a bit of dot notation. So we can go x equals math dot, we'll use a square root of 16. Now, I'm pretty sure you're going to get what this is. Let's have a look. Let's execute the whole code. And it's 4. Easy. So again, it's just one way of saving you from having to get the square root. You can use the math module for it. But again, go to docs.python.org and look in the /3/library, and you'll be able to search through essentially everything to do with the math module. In addition to the built-in modules, Python also allows you to create your own modules, which can be useful for you for organizing your own code and making it reusable, which we're going to do in a minute. Again, it's just as easy as saving out a file. But we're going to jump to that. Actually, let's talk about some of the other built-in modules at the moment, okay? Because they are pretty awesome as well. We can't just skip past them. So we've got import math. Okay, let's import random. Okay, let's use this one. Okay, and I'm using the pause okay in here just because I think I'm scared that some of these videos are going to get very long again and bore you. So, okay, don't worry if we've suddenly skipped ahead. Okay, we will explain through everything. So this code imports the random module, okay, and it demonstrates, let's demonstrate a few of its functions. So in our first example, all right, we are generating a random integer between 1 and 10. Pretty straightforward. So we're using random, using dot notation, we're going to go for random int, and there we go, simple as that. So let's see what we generate. Oh, we generated a 10 that time. What about the next time? 3, 1, 9, 5, 7. Okay, and again, it's a random number, so it could be 10 3 times in a row. It's like flipping a coin, which again, if you wanted to make a flipping the coin function, okay, you could just set it to 1 and 2, making 1 equal to heads and 2 equal to tails, and then literally you're just flipping a coin. So you see we're getting 2 quite a few times here because it's all random. Sometimes it'll be 1, 2, 1, 2. Sometimes it'll be 1, 1, 1. That's the best thing about the random function. It is very good at just giving you the random numbers you need. Again, it's not so useful, I don't think, within what context of what we do within Within Maya, but actually no, wait, it was. I mean, I've made a script that exploded an engine into different places and an asteroid. For a client, they wanted an explosion to happen, so I instead of and for it just to be passed to the animator so that they could animate how it looked. So I essentially just took all the parts that were modeled and exploded them out within the limit within space, and then they were animated by all the animators with the controllers. Okay, nice and easy. So yeah, I have used random a few times, but I think that's literally the only 2 cases I've probably used it in about 12 years, specifically within Maya. But we can also shuffle a list of items randomly. Okay, so we've got my list, okay, with integers 1 to 5. Okay, we've got random.shuffle, and then we're passing it my list. So let's see what we get. 4, 5, 2, 3, 1. 4, 2, 3, 5, 1. This is giving us a differently generated list every time, which I'm looking at. Sorry, I should have said. We're looking at up here. Okay, let's go back down. Okay, let's give a bit of a bigger window. Okay, and then output here. Let's clear it. All right, so we've executed all of our code here. And then if we print my list again now, it'll just be the same list. Okay, we have to regenerate everything happening. My list is now stored, but every time we go random.shuffle, it's actually shuffling the contents of my list. All right, so let's move on. So let's say we choose a random item from a list. So we've got our list here, and it contains apple, banana, orange. Okay, we've got our random item, and so we can go random dot notation, so dot choice, our list, and see what we get. So we've got our list, which is apple, banana, orange. We have then, from the list, we have got a choice, and we've got an orange. All right, let's do that again, see what we get this time. This time we've got an apple, a banana, apple, orange, orange, banana. See, again, very useful little function. It saves you having to randomize or make a random kind of set of functionality, which is not easy math, or not as easy as you might think it would be, making, a random math. Okay, so I think we've explained everything that these are doing here. These are pretty good examples. That's the random function, pretty useful. All right, let's move on. Let's go down to date time. So let's clear our output window. All right, here we've got date time, a really useful functionality. Let's get the current time and date. What we have to do, we've already initiated our date time. Let's use current time and then say datetime.datetime.now. And see, now we've entered that variable essentially and assigned the current time to it. So now we literally just have to print current time, and we get the current time is the 11th of April 2023, and the time is 17 past 8 and 50 seconds. The format the date as a string. Let's do that. So we've got today, okay, date time dot date today, and then the formatted date we are going to do using the string annotations. There we go. We have got our formatted date, and now we can print that. It says, yep, the 11th of April, or April 11, and we could format a little bit better. We could go okay. So April 11th, 2023. Again, we'd have to put some conditional code in there to say if it was a second or if it was a first. All right, but let's do something a little bit more interesting. Let's get the time taken to run a script. So this, we're going to actually also import time. And we're going to imagine that the time functionality is our process running. Okay, let's say it takes 2 seconds. Again, we can do .sleep, which essentially pauses our Python script when time is hit, pauses our script for 2 seconds. But here, what we're going to do is say the start time is datetime.datetime now. So we're going to get the start time of our script. And then we're going to say time taken equals our datetime.now or datetime.now minus the start time. Then we'll see what happens there. So now we're going to wait 2 seconds for it to run, and it'll print after 2 seconds. Brilliant. So we can also then give ourselves a really nice little F string that gives us quite a good bit of information. Like I use this when I'm doing a massive build, because I want to know how long each machine is taking essentially to do a build of my rigs. If there's any issue, or if it starts getting slower than a few seconds, then I know something's going wrong, or I'm doing some loops that are slow, or essentially I'm not writing my code well. I want my rigs to be able to build in just a couple of seconds. I don't want to put okay, months of work into a few seconds. I don't want it to feel like it's taking months as well to run the script. Yeah, let's move on. Let's actually start creating our own module now. We'll use this in Sublime for a nice easy example. Later on, we're going to probably move on to PyCharm. But I'd say we start now with something really simple and give you an example of Sublime as well. And just to create a simple module, we need to create a file with the extension py or .py. And you see within my D drive, I've got my test folder, and I've got my first module.py. This has already been saved. And now what we're going to write into this, we're going to give it a definition. We're going to give it greeting and name. It's taking one argument. From that, we're going to go print. We're going to give it a little f string. And we're going to go hello. And then we'll go curly brackets name. And so you see what I mean about IDEs being a little bit more readable. This is why I don't write code too much in Maya, just because, again, I've got all the, I've got quite a lot of information here. So as you saw a minute ago, I've got quite a lot of drop downs. I've got a lot of information that gets given to me when I'm writing. I've got all of these kind of automatic automatic gifts that are going to essentially given to me, the plugins through Sublime, that if I need them, just help me, again, write code a little bit quicker. I can go through all of these types and just write any of these. Click of a button, quite nice and quick. But anyway, I digress. We've got our greeting stored within our myfirstmodule.py file. All right, now let's use this. So what we need to create now is another file called greeting. So let's save this. What are we going to call it? Yes, we will save this as greeting.py. And so what this is going to do is import my first module. And then we are going to use that, and we are going to say my first module dot greeting, which you see is already coming up and prompting us. And then we're going to pass the name to it, which again, we're already getting the prompt here. This is why, again, IDEs are so great. But we're going to say Nick, my name. So to run this script within Sublime, we have to press Control, Shift, and V. And we get hello, Nick. Okay, perfect. So let's try this with a new name. Okay, let's try Jonathan. Okay, we'll run that with Python. Hello, Jonathan. Created in, or finished in 80 milliseconds. That's pretty good. Great. So we can also import this in a different way. So we can go like this. So press execute to get rid of the output. So go from, okay, my first module, import, greeting. And even there, you see I'm getting the prompt, so I can just click enter. Okay, now what I have to do is just remove this first module, and then we've got greeting. Go back to being Nick, and then we'll just press, again, Control, Shift, and V. We get hello, Nick. So nice and easy. Essentially, it's just giving us, again, a lot quicker way of writing our code and being able to reuse it. We can also use namespaces as well. So we could also set a namespace and say greeting as greet. So again, let's say you had another module for some reason called greeting. You wanted this one to be called greet. So make sure you can differentiate. And the other one was called initial greets. And then another one was called later greet. I don't know why, but okay, let's go with this. So Python. So you see, again, we're now using a namespace. Again, be careful with namespaces because unless they do add readability, they can make your imports look a little bit messy. There is another way of importing everything, the code that you need, but I'm going to tell you shouldn't use it because for best practices, I'd say you shouldn't use it. We can use an asterisk. Now, this magic asterisk is both a good and a bad thing. So let's say you have a module that has 50 different functions within it. That's good, but it's also bad. I'd say that you need to maybe look at creating some new modules, breaking down these functions into different groups, saying what they do. Okay, make a new folder, Maybe if some of these are utility functions, some of these are math functions, break them down into what they do and try to segregate them a little bit so that it makes your imports a little bit more obvious. Because at the point that you're using a star to just import all functions, it's not going to be good for anyone debugging. Because now if I get an error sometimes, it's going to tell me, especially within Maya, that it's just an error, okay? Or within my ID, it's going to tell me it's an error and it won't always trace back to where it came from. And that's going to be then made more difficult, especially if I'm looking through the code to start seeing, okay, well, this error was on this module. Okay, but there's an error that comes from that module, but where's it being imported from? Because you can't now see where greeting is coming from. Greeting, if I'm looking at, okay, there's an error in greeting. Okay, well, where did greeting come from? Well, we can't see that because we haven't included it up here in the window. So make sure you don't use the asterisk just to import all. That blanket kind of bombing all import all is not good. Try to make sure readability is first, okay? Even if you have multiple arguments that you have to split on different layers, you go greeting, okay, and then saying goodbye. So let's say you have another module saying goodbye. Okay, you'd separate these with a comma. You could have another one saying, what could we have another one saying? We could do our hello world in here as well. And again, see, I'd rather that we had too many modules, but I essentially split them out like this so that we said my first module, and then I'm reading out the list of imports here. Because again, I know that you could have a lot, but this is where, again, you have to tidy up your code. And like we're doing, refactor your code so that you do less of these imports. Or you just use my first module and then go .greeting. If you feel like you've got quite a lot getting there that's not increasing readability, then increase readability in a different way. Try to use the my first module greeting. There are different ways of accessing these. And so an example of this would be obviously how we get Maya. Okay, we can get Maya commands as M. So import Maya.commands and then use the namespace M. Now, I'd say this is a nice short piece of code. It's very obvious what it is. It's Maya.polycube. We always know that M dot is Maya dot something. Okay, Maya functionality. You'll also see it done a lot with commands, but I don't care for it just because it's just as easy to read as M. Let's step it up a gear. Within our first module, let's also add person1. This is a dictionary. Again, so variables that are meant to be kind of used globally by other modules and that store information that is pivotal to the running of functions or variables at the base level. I'd say they should always be uppercase. There's quite a few Python methodologies that would state that as well. Okay, increases readability again. So let's say person1. This is a dictionary including the name, age, and country. So Sam, 36, Norway. And then in greetings, we can say import. So my underscore first module. And then we can go A equals copy my first module dot person. Oh, here we go. See, I spelled that wrong straight away when I could have just used, okay, person1. Much easier. And then actually we're going to get that person's age. So we're going to go age. Brilliant. Let's run this Python script. And we also need to print really to actually get an output from it. So let's go print. And then we get 36. Okay, perfect. Great. But we can also, again, go from Python module import person1. And that will allow us, again, just to cut out that bit of code there. And I'd say, again, increases readability here. So might be worth, again, using the import, using from and then import. It's a lot more readable, the less code you have to write. Brilliant. And then we can just go print. Okay, person1, age, easy, done. That's an introduction. into everything you need within your file. So again, we're just within one folder here. Okay, we've saved 2 Python files with .py. We've got our first module, which has a function, greeting, and takes the name argument. And then we're just printing out, again, we're using 2 spaces here. Probably should use 4. So I don't know why we're tabbing to 2 here. That is strange. Okay, which again, indentation, let's set it to 4. So now, okay, we can just tab and it'll go in 4. Okay, pretty straightforward, nice. Always a problem when you download an IDE to give an example. Got to remember to set everything up exactly as you want it. Great. So, like I said, we've got our greeting function. We've got our person1 variable, which holds onto a dictionary with name, age, and country as its keys, Sam36 in Norway as its values. And within greeting, we've then got a little bit more information. We've got our first module and importing person1, but we can also import greeting this way. Okay, and you can encapsulate them within parentheses, but you don't necessarily have to. So let's have a look at what we could do actually with this. Let's do greeting, then person1, name. Right, and then we'll just click, sorry, I'm highlighting now just because I'm so used to working in Maya now for the last few nights. And then we can go, hello, Sam. We have used our person1 that we have got from the my first module, and then we are running it through the my first module greeting functionality. So you see, again, this is all nice and easy. We can store our functionality somewhere, okay, and all of our functions that do the tasks or have all the variables, like common names we could put into a into one module. You can have common just for very common functions, and then you can have somewhere else where you're actually calling them. You can have a build script, so you can do build leg, and then you can have build biped, build quadruped. You can have everything separated out and broken apart bit by bit. And obviously this test folder could have multiple folders below it. Okay, you could have build, animation, control, utils, okay, and each one of those again has folders within it. Those won't necessarily call each other via Python because they need to have an init file in it, but that literally just looks like this. So let's have a quick look. So save this. We're going to call this underscore init _.py. So now within a library situation, when you're importing all of these libraries, this init functionality helps us grab onto all of the other modules, okay? All right, if we don't have this, Python, when it's reading through the module folder that you've passed to it, it won't look through this folder because you haven't said to initiate it, which again, we'll talk about a little bit more later on. Oh, yeah, we could just talk about it. So, okay, so the init, let me just rack my brain. So in Python, so the magic methods essentially that we're looking at, the init file is special because it's used to mark a directory as a Python package, essentially. So when a directory contains the init file, Python treats that directory as a package. Okay, this allows you to organize your modules into a hierarchical structure like we just talked about, where you have subfolders and files, so that you can, again, organize them a bit more of a tidy way for you to kind of call with your importing and your from here, import this. So the file can be empty, but it can contain code as well. It doesn't, I normally just use them as place markers, but because I like to have specifically named files, but it doesn't matter. You might use the init as well to kind of import submodules, okay, referring them back. So you might, so for me, I use an init within my nodal setup so that I can have various complexity to the folders below my nodal setup, but then import my DAG node, my dep node, my curve, my joint nodes, all to that base, towards that base folder structure, so that, again, it reduces my code when importing. And I know I'm doing this, but I can still also then import them if I'd like to directly from that folder, from the folders that they're actually created in. It doesn't matter. The error message will always still point back to that original folder. So yeah, that is in it. I'll make sure I include something about that within the notes for when you download them. But okay, let's head back to Maya. And we'll talk about some common errors associated with modules. Let's have a look. Oh, I did write quite a few of these, my goodness. Okay, let's have a look. So So forgetting to install required modules. Yeah, I mean, always. Everyone does this, and don't worry, it's very common. Forgetting to install the required modules is very common. It's easy to install or to run a module that you've forgotten to include within your Python library or within your series of libraries. If you haven't got the init as well, it might not be called. But all you need to do is install it separately using maybe a manager like pip and pip install. If you need to search that to understand, yeah, please do. Okay. But forgetting to install a required module can result in the module not found error. So you will be told about it as well. So I wouldn't worry so much about it. But yeah, that's basically all that. You've just got to make sure that when you first start writing your modules within your library, you set up a few simple prints so that you go, okay, print this, and then you'll go, oh, okay, great, yeah, okay, yeah, it's all working, it's great. Don't start writing loads of modules and then realize that everything's set up wrong and then panic yourself because you're like, oh, well, what have I set up? I'm gonna have to change everything. Okay, test early, test often. Naming conflicts. If you import multiple modules with the same name, so like we've said with namespaces, namespaces are basically there for that very purpose, to rename various modules. If you've got a math module as well, which has various functionality like square root, sine, circumference, radius, it gets you certain calculations in a certain way, but you also have another module that does it, then make sure that you use namespaces to make them readable. Naming conflicts are just annoying and they make it very hard to debug because obviously Python doesn't know what to look at. It'll basically just either look at the wrong module and then give you an error, which will confuse you because as far as you know, you're using the right module. But again, that's more of a logical kind of problem. All right, so yeah, as we've said, just try and make sure that you use namespaces and try not to import too many modules with the same name. Circular imports. Now this one, oh yes, we didn't talk about this, did we? So circular imports. A circular import occurs when two or more modules depend on each other, so either directly or indirectly. Now this can result in errors unexpectedly crashing most of the time, or just giving you errors out essentially. So a circular dependency will look like this. Okay, so within greeting, so we're importing something now from greeting, but within my first module, let's say we set a function in here that was said, make name upper. And this returns name just dot upper. Easy. But let's say within your my first module, you now imported, okay, so from, actually just import, so from, we're doing greeting, make name upper. Oof, yeah, there we go. So we're getting a little bit of an awkward error here. What are we getting? There we go. So import error, that's the one. Nice and simple, okay? So cannot import name, okay, make name upper, because it's from a partially initialized module greeting, okay? And most likely due to a circular import. So even then, actually great. I've not had this problem in a long time, but it didn't used to tell you it was a circular import in quite a few versions of Maya ago, especially in version 2. Okay, so that is awesome. That is a really good update that they've had there, because now you even know it's a circular import. You didn't used to know that. You just used to get, unexpected behavior. But brilliant. Okay, so what we're doing is you see the problem here is we're trying to import from greeting, but then from greeting, we're trying to import from module. So the second that we import from one, we're importing from the other. It's just going to essentially make a little circular dependency in a circular loop. All right, great. Let's go back to Maya. So yeah, again, that's circular imports. Importing too much, okay? Like I said, with the asterisks, you don't want to import everything, okay? Just blanket import everything because you'll start slowing your script down if you're constantly importing everything. If you need a specific function, import that. It'll make everything more readable, much easier to look at. Again, it basically just leads to slow performance and harder readability, so just bad principles of programming, okay? Or bad practice. Incorrect import syntax, using incorrect syntax when importing. So using the incorrect syntax when importing modules can lead to syntax errors and unexpected behavior. You'll be pointed at where they are. But for example, forgetting to include parentheses when calling a function. Trying to modify imported modules, okay? this isn't going to go well for you. I've actually got some of this. Okay, interesting. But okay. So modifying a module can have unexpected consequences, especially if other parts of your code rely on the module's original behavior. It's usually better to create a copy of the module and modify that instead. All right. Not keeping modules up to date, as we've said. This is important. As with any software modules, they can have bugs, more security vulnerabilities, or readability issues. And they can be fixed in later versions, but failing to keep the modules up to date can leave your code vulnerable to these issues. But for us, we're not dealing too much with security at what we're doing. And if you are, then this is very important to you, but just make sure you keep your code up to date. Make sure you also make sure your docs are up to date, mostly for readability and for your team to have a good time. All right. So to avoid these common mistakes, it's important to carefully review your code when importing and using modules to stay up to date on latest and best practices for Python development. Great, so good job, okay? In this video, we have learned about modules, how to use them, common errors, and yeah, we've also run through some examples. So yeah, well done, good job. Thank you so much for listening, and I look forward to seeing you on our next video.